Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, let's look at some questions that deal with the relationship between weight and mass. So the first question we have here is, what is the weight on Earth of an average man? So first I need to decide what I think the average mass of a man is on Earth, and I'm going to go with roughly 80 kilograms. Okay, and then I need to write down my equation. So weight is equal to mass multiplied by g. And then all we need to know is that on Earth, our G, which is our gravitational field strength, is 10. So simply all I have to do is multiply 80 by 10, which gives me 800 newtons. Okay, and then the next question is, how would this be different if the man were on Jupiter? It tells me that on Jupiter, G is equal to 25 newtons per kilogram. So again, we write my equation down first. Weight is mass times g, and this time I'm just going to multiply that 80 by 25, this new gravitational field strength for Jupiter, and that gives me 2000 newtons. Okay, and then this final question here is, what is the mass of something on Earth that has a weight of 65 kilonewtons? So again, let me write down my equation. Weight is mass times g, but this time I'm looking for the mass. So I'm going to need to use a rearranged form of that equation. So to get mass by itself, I'm going to divide both sides by g. Okay, so mass is weight divided by g. And then I need to do something else. I need to make sure that in my equation, my weight here is meant to be in newtons. In my question, it's been given to me in kilonewtons. So before I plug it into my equation, I need to transfer that into newtons. So 65 kilonewtons is 65,000 newtons. And then to divide that by G, which is 10, and that will give me 6,500 kilograms. Okay, moving on to circular motion now and some more explanation style questions. And the first one we have on the left is, what is the direction of the centripetal force? And the word centripetal actually means center seeking, and all of these centripetal forces are indeed acting towards the center of the circle that your object is moving in. Okay, next question. Why does an object moving in a circle require a centripetal force? Okay, we need to know that in order to move an object around in a circle, you need to be applying a resultant force to that object. Why? Because that object, by moving around in a circle, is indeed accelerating. And by that we don't mean that it keeps changing the speed that it's moving at. That is simply to do with the fact that it keeps changing direction as it moves round. And since my acceleration is actually to do with the rate of change of velocity, and my velocity is a vector quantity which involves direction, if my thing keeps changing direction, it is accelerating. So I've written here, acceleration, constant change of direction. Basically, what would happen to my object otherwise if there were not a centripetal force acting on it is that it wouldn't continue in a circle and it would just fly off at a tangent. Okay, what is the centripetal force acting as the hammer is thrown in the Olympics? So this is just the idea that your centripetal force is this umbrella term, but actually any individual force can provide that centripetal force. So you need to look at your particular example. In the instance of the hammer being thrown in the Olympics, that would be the tension in the string that's keeping this round in a circle. Okay, if I was interested in which force is it that keeps my Earth moving around the sun, in that context it would be the gravity. Okay, but the tension and the gravity, they're both centripetal forces, center-seeking forces. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, tips and tricks for this section. So firstly, my factors that are affecting your weight. So basically, it will depend on the distance that you are from your planet. So we say that on Earth, G is equal to 10, and that is true at the surface of Earth. Actually, if I were to go further and further away from Earth, I would find that that G got smaller and smaller. And the other thing that affects it is the mass of the object and the planet. Okay, so the larger the mass of the Earth and the mass of me is, the stronger that attraction is. Force meter versus mass balance. Yeah, these are just the different equipment that you might use to measure a force or a weight versus measuring a mass in kilograms. So your force meter gives you something in newtons or a force, and your mass balance gives you something in grams, or it could be kilograms. Remember, as it says on my next point, your mass is in kilograms in the formula. So if they do give you a mass in grams, make sure to convert it first. And you do need to learn that on Earth, G is equal to 10. Okay, you will not be given that in your exam.